Hey guys, and welcome to the first lesson of Unit 3. We are going to do a little bit of trig review today. So we'll start off with some stuff we've learned in grade 10. Now remember that when you're given a right triangle, we can figure out missing sides and angles using the SOHCAHTOA rule. So basically, if this is the angle that we are working with, then that tells us that this side here, AC, would be the opposite side. The side CB would be the adjacent side, and always opposite of the right angle is the hypotenuse. So if you recall our SOHCAHTOA rules, sine is the ratio of the opposite over the hypotenuse. Cos is adjacent over hypotenuse. And tangent is opposite over adjacent. Now we're going to kind of apply that to our grid. So let's imagine our initial arm being on the x-axis, on the right side of the x-axis here. And basically we take that arm and then we are going to rotate it counterclockwise to create this angle theta here. And so then we end up with this point or this line, and a point that lies on the line here, we'll call it point P. And that point P has coordinates x and y. So basically to get to that point, we moved to the right x units and we moved up y units. And basically if we took that initial arm and rotated all the way, that would create a circle. So essentially this line that we created here is the radius of that circle. So that's why it's labeled as R. Now to kind of relate what we did above, our SOHCAHTOA rules, we're not going to use opposite and hypotenuse and adjacent anymore. We are going to talk about, or we are going to use the variables x, y, and r. So instead of opposite over hypotenuse, the sine ratio is going to be y over r. The cos ratio is going to be x over r, and the tan ratio is going to be y over x. And another thing to point out is that x and y both can be positive and negative values because those are points. Those are coordinates on a plane. The r value has to be positive because the r value represents the length of a radius. That could never be negative. Okay, so x and y is okay to be negative, but r always is positive. Now, sometimes to determine r, because what we've done here, you might notice that we've created a right triangle. So we can use the Pythagorean theorem at times to help us find those values for x, y, or r, depending on the situation. Okay, so some other things to kind of recall. Remember from last year we had the cast rule. So ratios that ended up in the first quadrant here ended up all being positive. Ratios in the second quadrant, only the sine ratios were positive. In the third quadrant, only the tan ratios were positive. And finally, in the last quadrant, we have all cosine ratios were positive. So remember your cast rule. The other thing that we need to remember is our special triangles. So in our 45, 45, 90 triangle, this yellow triangle here on the left, remember that the legs of the triangle are both 1 unit and the hypotenuse is root 2. In the 60, 30, 90 triangle, opposite of the 30, so opposite of the smallest angle is the smallest side. So that might be helpful to remember. So opposite of the 30 is a side that is 1 unit in length. Opposite of the 60 is the root 3. And then opposite of our right angle is a side length of 2. Okay, so those you need to have memorized. Now we'll talk a little bit about terminology. So coterminal angles are angles that are standing position that share the same terminal arm. So for example, if I started in standard position, so if I had a line that was in standard position and I took that line and I rotated counterclockwise, I've created this terminal arm right here. Now a coterminal angle is basically a line that again starts in standard position, but let's say I rotated that much. I eventually ended up with the exact same terminal arm. We ended up in the exact same place, and that is what a coterminal angle is. They're always multiples of 360 degrees apart from each other. So let's say that blue angle that I first drew was 45 degrees. Well, 360 degrees away from that would give me an angle that I created that is 405 degrees. So this green angle that I drew up here. So two other coterminal angles to 45, well, let's take this 405 and add 360 to it. So if I took 405 and added 360, I would end up with another angle that is 765 degrees. I could take that angle and add another 360 to that, and I would end up with an angle 1125 degrees. The other thing I want to talk about is positive and negative angles. So again, in standard position, when we rotate counterclockwise, that is when we're talking about positive angles. If I wanted to draw a terminal arm that was 120 degrees away from standard position, well, I would start in standard position here, and I would rotate counterclockwise about 120 degrees here. And I would label this angle here as 120. Our terminal arm has landed in the second quadrant. Now, when we rotate clockwise, we talk about negative angles. So again, we start in standard position, but this time I'm going to rotate clockwise, 30 degrees. So I don't label this as negative 30. The angle is still 30 degrees. The negative just told me which direction to go in. So in this case, negative 30 is located in the fourth quadrant. And one other thing that we talk about a lot is the related acute angle. So the angle measured from the terminal arm of an angle in standard position to the x-axis. So, for example, let's take a look again at this angle 120 here. The related acute angle would come from, let's say, me dropping a line right from the terminal arm here. I would drop a perpendicular line towards the x-axis, and then I would calculate this angle here. So I know that a straight line is 180 degrees, and I already know that this angle here is 120 degrees, so the related acute angle must be 60. So we reference that a lot in this chapter. Okay, some identities to talk about that you've probably seen last year. Remember that the tan identity, so tan theta, can be rewritten as sine theta over cos theta. And again, from the first slide, remember that tan theta is y over x. The Pythagorean identity is sine squared plus cos squared equals 1. Okay, so if you see sine squared theta minus cos squared theta, that's a whole other identity, and we'll talk about that in the next chapter. This actually can be rewritten to help you solve for other things. So for example, I could rearrange the formula to isolate sine squared theta, and so sine squared theta would just be 1, and then move this cos squared theta to the other side. So 1 minus cos squared theta. Similarly, we can isolate cos squared theta and replace that with 1 minus sine squared theta. So all three of these could be quite helpful when you are working with identities. Now the reciprocal identities, cosecant theta is really the same thing as 1 over sine. So if sine theta is y over r, then cosecant theta is just going to be the reciprocal, so r over y. Secant theta is the reciprocal of cos theta. So secant theta is 1 over cos theta, and again, if cos theta is x over r, then secant theta is just the reciprocal. It's just flipped, so r over x. And cotangent is really the reciprocal of tangent. So if tan was sine over cos, then cotangent is going to be cos over sine, and again, if we're talking about variables, then tangent is y over x, and cotangent is x over y. So all three of these types of identities you should get familiar with and make sure that you are comfortable with working with them. So we'll start some examples now. The first one we're going to talk about is the point 2, -9, lies on the terminal arm of an angle theta in standard position. So let's approximate 2, -9 on this diagram over here. So 2, -9 is probably somewhere around here. And that lies on the terminal arm of angle theta. So again, remember what that means. We started in standard position and then we rotated counterclockwise. So the length here in purple, that is our angle theta. We want to find the exact values of sine, cosine, and tangent for the angle theta. Now what we're going to do here is we're going to use that related acute angle that I talked about earlier. So I'm going to take this point here and I'm going to drop a perpendicular line towards the x-axis to create a right triangle. And again, remember from the very beginning of the slide, this point 29 was created by starting at 0, 0, and I know that we went right on the x-axis 2 units, and I know that we went down on the y-axis 9 units. So I can say that x is 2 and y is -9. So the first thing we're going to do is find that missing side length using Pythagorean theorem. We're going to find that missing r. So remember, x squared plus y squared equals r squared. Just go ahead and fill in the values and solve for r. So x squared plus y squared equals r squared. So I know that this is 4 plus 81, giving us r squared equals 85. And then finally, r equals, now normally when you take the square root of both sides I would do plus or minus, but because I know r always has to be positive because r represents the length of this line, I'm just going to do the positive square root of 85 and we'll leave it exact. So now that we know that r is the square root of 85, we can go ahead and create those ratios for sine, cosine, and tan. Again, remember that sine theta is the ratio y over r. Well, from above, we know that the y value was -9, and we found that the r value was root 85. Cos theta, recall, is x over r. Well, the x value from above was 2, and again we found the r value to be root 85. And then finally, tan theta is y over x, y from above, and x from above. And that's it. That's all the question was asking you. So determine the exact values, no decimals. And that's why we left all of our answers with radicals on the bottom. Okay, moving on to the second example. We want to find the exact value of each of the following. So I want to find the value of sine 225 degrees. So because the angle was given to me, I'm going to locate that on the graph. So remember, we're going to start in standard position, and we're going to rotate 225 degrees. So I know I'm going to end up in the third quadrant somewhere. And again, we are going to drop down that perpendicular line towards the x-axis. Okay. Now, what I really want to know is that related acute angle. So yes, I know that this purple angle here is 225 degrees. I also know that that a straight line has an angle of 180 degrees. So if I subtract 225 and 180, I will get the related acute angle, which is 45 degrees. So just the angle from our terminal line to the x-axis. when we see a right angle triangle with one of the angles being 45, well, that tells me that the other angle must also be 45 degrees. And at this point, you should be thinking special triangles. Now, in a special triangle with 45, 45, 90, I know that the legs of the triangles are going to be 1 and 1, and the hypotenuse of this triangle is going to be square root 2. Now, the way I like to label these diagrams is I like to put the signs of the value. So, for example, the R value, like I said before, is always going to be positive. However, this value here represents my X value. So if you can imagine a point here with X and Y, the X value here is going to be -1 because we went left on the X-axis. And if you went down on the Y-axis, that is also going to be negative. So this point here, if you really wanted to imagine, that would be -1, -1. Okay, in any case, like I said, I like to put the value on the graph. So what we're looking for here, so sine of 225 is going to be y over r. Now we have found that the y value is -1 and our r value is square root 2. So by using that related acute angle, we were able to determine the side lengths as 1, 1, root 2, and based on where it ended up in the third quadrant. That tells me that only the tan ratio is going to be positive, so I know that sine is going to be negative. And again, I verified that by actually putting the negative signs on my graph. Okay, so we'll try that again. So cos of -300. Remember, now what we're going to do is start at the standard position, and we're going to rotate clockwise this time, 300 degrees. So if I go ahead and do that, I end up actually in the very first quadrant, so somewhere around here. Again, drop down that perpendicular to make a right angle triangle. So if this purple angle is 300 degrees, what I really need to know is that related acute angle. So a full circle is 360 degrees. This purple angle is 300 degrees, so I must be left with 60 as my related acute angle. Now in a triangle, I know that 60 plus 90 plus 30 will give me 180 degrees. Now again, we have the 30, 60, 90 triangle. That's another special angle, or special triangle. So that special triangle says, well, opposite of the 30 would be a side length of 1. Opposite of the 60 would be a side length of root 3. And then finally, the hypotenuse would be 2. Now double check. If I went right on the x-axis, well, my value here should stay positive. And if I went up on the x-axis, my value here should also stay positive. And no matter what, the r value is always positive. Okay, so back to our question. We know we're trying to find cos of -300. The cos ratio is x over r. So our x value is 1 and our r value is 2. And that would make sense to be positive 1 over 2 because anything in the first quadrant, all ratios are going to be positive. Now finally we'll do cotangent of 150. Let's place 150 on our grid. So somewhere in the second quadrant will be 150. We'll drop down our perpendicular to make that right angle triangle. That tells me that my related acute angle is 30. And finally, the missing angle here would be 60 degrees. Now, again, put in those values because we have a special triangle here. So put in those side length values. Now, opposite of the 60 is root 3. But remember, we're going left on the x-axis. So I'm going to put a negative root 3 there. Opposite of the 30 is 1. We went up on the y-axis, so that'll stay positive 1. And the hypotenuse is going to be 2. Remember, cotangent is the reciprocal of tangent. So its ratio is going to be x over y. We know our x value is negative root 3, and we know our y value is 1. So just to simplify, we end up with negative root 3. And again, a negative root 3 would make sense because only in the second quadrant, only the sign values or the sign ratios are going to be positive. So clearly a cotangent or a tangent would be negative. So it makes sense to have the negative there. Okay, so we will now move on to example 3. This time we are not given the angle theta. We have to find the angle theta. Okay, so we want to find two values for theta on the interval between 0 and 360 degrees. So basically in this circle. So the first thing we want to do is take a look at the sign of our ratio here. That will determine which quadrant we are going to draw our lines in. Okay, so a sign ratio that is negative, let's recall our cast rule. So C-A-S-T. Well, sign is going to be negative in the tan quadrant and in the cos quadrant. So what I'm going to do is I'm going to draw two lines, one in the tan and one in the cos quadrant. Now the second thing that we're going to do is look at the ratio to determine our side length. So we've created two right triangles here. So take a look at our ratio here. We have a sine ratio, and we know that the sine ratio is y over r. So that tells us that the y values are going to be 1, and the r value, the radius, is going to be root 2. So we can plug that in our graph. So r is going to be root 2, and our y values are going to be negative 1, which makes sense because we went down on the y-axis. So taking a look at this, it looks like the beginnings of another special triangle, the 1, 1, root 2 triangle. So I know that those missing sides are going to be 1, and I also know that the missing angles, the related acute angles, are going to be 45 degrees based on the special triangles. Okay, so now that I've determined what these related acute angles are, I can determine the two values for sine. So what we've really done here is we've created two terminal arms. The first one, as always, it starts on the x-axis here, and we're going to rotate until we hit that very first terminal arm. Now I can determine the angle, I can determine the value of that angle that I just drew there. So I'll call that number 1. Now, I know that from x-axis to the other side of the x-axis is 180 degrees, but we went 45 degrees further than that. So basically, to determine the first theta, I'm going to do 180 plus 45, and that will give me 225 degrees. So one possible answer is going to be 225. Now let's try again. We'll start at standard position, and we're going to rotate counterclockwise until we hit the second arm. Now, if I had gone full circle, that would have been 360 degrees, but I know I stopped 45 degrees before that. So to find the second possible answer, I'm going to do 360 degrees, take away 45, and that gives me 315 degrees. Now you can double check. Make sure your calculators are set on degrees and go ahead and do sine of 225. Do you get a value of negative 1 over root 2? Try again doing sine of 315. You should also get a value of negative 1 over root 2. So it's a good way to double check your answers. Okay, and finally, the very last example, we have 4 theta in standard position with its terminal arm in the 4th quadrant. So we're just going to highlight that for now. We're going to come back to that in a second. That's going to be important. We know that the ratio for cos, so cos theta, is 7/25. We want to find the exact values for sine theta and tan theta. Now again, remember that sine theta is y over r, and tan theta is y over x. We're given cos theta, which is x over r. So essentially what we're missing to find sine and tan is that value for y. So the first thing that we're going to do is, well, I'm a very visual learner, so I'm going to roughly sketch a terminal arm in the 4th quadrant. I'm going to drop down that perpendicular so I have a right angle triangle there. And I know the values for x are going to be 7 and the value for r is going to be 25. So basically we need to find out what y equals. And again, from the first page, we are going to use the Pythagorean theorem. So step 1, we're going to find y. So x squared plus y squared equals r squared. And so we're filling what we know. I know the x value here is 7. We don't know the y value, but I do know that the r value is 25. So if we go ahead and simplify that a little bit, we're left with 49 plus y squared equals 625. We'll move the 49 over, so 625 minus 49. And if we square root that, now remember we're going to square root, and y can be negative here. So doing the positive or the negative values of the square root is important. So we end up with y could be either positive or negative 24. But how do we know which one it is? Is it positive 24 or is it negative 24? Well, that is where the 4th quadrant is very important. Okay, because in the 4th quadrant, as you can see from our diagram, in the 4th quadrant, we go down on the y-axis. So the only one we're going to focus on is y equals negative 24. Okay, so now that we've determined that y is negative 24, we can figure out the ratios for sine being y over r. So now that we've found y, I can say that it's negative 24 over 25, and for tan, which is y over x, I can say that this value is negative 24 over the given value of x equals 7. And that's it. So those are our 2 answers. So that's it for today's lesson. Again, if you have any questions, make sure you ask in class. Take care, guys.